Hello everyone, this is Karthikeyan. I am a candidate master on code forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals, 2020 rank 27, global rank 251 in Google Kickstart Round Day 2021. And today I am going to discuss the problem walk, which was asked in March Challenge 2014. The difficulty level of the problem is Cakewalk, the prerequisites are none, and the number of accepted solutions during the contest were 4092. Now let's move on to the problem statement. So, Chef and his girlfriend are going to have a promenade. They are walking along the straight road which consists of segments placed one by one. Before walking, Chef and his girlfriend stay at the beginning of the first segment. They want to achieve the end of the last segment. There are a few problems. At the beginning, Chef should choose a constant integer, the velocity of moving. It can't be changed inside one segment. The velocity should be decreased by at least 1 after achieving the end of some segment. There is exactly one shop on each segment. Each shop has an attractiveness. If its attractiveness is W and Chef and his girlfriend move with velocity V, then if V is less than W, girlfriend will run away into the shop and the promenade will become ruined. Chef doesn't want to lose her girl in such a way, but he is an old one. So you should find the minimal possible velocity at the first segment to satisfy all the conditions. So now I would explain you the problem statement in simpler words. So basically in this problem we are having n segments and each segment has exactly one shop. Now every shop has some attractiveness which is denoted by A of I, which is the attractiveness of the ith shop. Now if, while passing through this segment, the velocity of the chef and his girlfriend is v, and v is less than a of I, then girlfriend would run away and the promenade will get ruined. So, we don't want the promenade to get ruined. So, the velocity at every segment v should be greater than equal to a of I. And there is one more point to note, that the velocity at the end of each segment decreases by 1, by at least 1. So let us assume that if the velocity at the ith segment was v of I, then the velocity at the I minus 1th segment or I plus 1th segment would be equal to v of I minus 1. It would at least decrease by 1. So now let us work on the first sample test case. In this sample test case, there are 5 shops and the attractiveness of the shops are 6, 5, 4, 3 and 2. Let's work on this test case. 6, 5, 4, 3 and 2. Let us assume that the velocity at the beginning is v. So at this point it would be v minus 1. At this point it would be v minus 2. At this point it would be v minus 3. And at this point it would be v minus 4. And in order for the promenade to be successful, v should be greater than equal to 6. V minus 1 should be greater than equal to 5. V minus 2 should be greater than equal to 4. V minus 3 should be greater than equal to 3 and V minus 4 should be greater than equal to 2. So in this way, V should be greater than equal to 6. This is the first expression. In the second expression, V should be greater than equal to 6. And in the same way, in all the expressions, V should be greater than equal to 6. So the answer would be 6. Now, let's move on to the second test case, which is 3, 4, 3, 1, 1. So for this test case, these are the attractiveness of shops at the ith segment. Now, let us assume that the velocity is v. Then it would become v minus 1 at this point, v minus 2 at this point, v minus 3 at this point, and v minus 4 at this point. Now, v should be greater than equal to 3. V minus 1 should be greater than equal to 4, which implies v should be greater than equal to 5. Okay, v minus 2 should be greater than equal to 3, which implies v should be greater than equal to 5. V minus 3 should be greater than equal to 1, which implies v should be greater than equal to 4. V minus 4 should be greater than equal to 1, which implies v should be greater than equal to 5. So the velocity must be at least 5 in order for the promenade to be successful. So now let's derive a formula for this particular question. Let us assume that there are n stops. The stop number 1, stop number 2, stop number 3, stop number 4 till n stops. Now, when you are at the ith stop, then the velocity would have decreased by I minus 1. So, if the velocity at the beginning was v, and when you are at the ith stop, it has decreased by at least I minus 1, then v minus I minus 1 must be greater than equal to a of I. So v should be greater than equal to a of I plus I minus 1. And our answer would be maximum of a of I plus I minus 1 for every I. For every I from 1 to n, because this is the velocity that chef must possess in order for his promenade to be successful. Now let's move on to the code corresponding to this approach. Here is my code. So here n denotes the number of shops, a denotes the attractiveness of the ith shop, I will store the answer velocity in the variable answer. Here I am taking input the attractiveness of the shops. Now, the minimal velocity in order for the promenade to be successful at this particular stop should be at least a of I plus I minus 1. It should be at least greater than this, because initial velocity would have decreased by I minus 1, and if the initial velocity was v, then v minus I minus 1 should be greater than or equal to a of I. So v should be greater than or equal to a of I plus I minus 1. And the answer would be the maximum of answer comma velocity. After this, I would print the answer for this test case. Now let's try submitting the solution. Meanwhile, the submission is being queued. I will tell you the space and time complexity of this approach. The space complexity of this approach is order of n, and the time complexity of this approach is order of n as well. As you can see, the solution got accepted. So if you have any doubts regarding this approach, you can ask in the comment section, and thank you for watching the video.